So today first we are going to see entity types, entity sets, keys and value sets. So first we are going to see entity type. So entity type. So what is entity type? Entity type is nothing but a database usually contains groups of entities that are similar. For example, a company employing hundreds of employees may want to store similar information concerning each of the employee. These employee entities share the same attribute, but each entity has its own values for each attribute. So therefore, an entity type defines a collection entity type defines a collection or set of entities that have the same attributes. So each entity type in the database is described by its name and attributes. So figure 7.6 is an example of entity type, employee and company. So here two entity types are there, employee and company. So employee is an entity type, company is an entity type. So here what we are seeing, the collection of all entities for a particular entity type in the database at any point in time is called entity set. The entity set is usually referred to using the same name as the entity type. For example, employee refers to both type of entity as well as the current set of all employee entity in the database. Okay, entity type is basically nothing but entity. Here one entity type is nothing but employee, another entity type is nothing but company. Okay, so here after that, this is entity type. Entity type we understood, and then after entity type we have this key attributes on an entity types. Okay, so what is key attribute on an entity type? An important constraint on the so what is key attribute? An important constraint on the entities of an entity type is the key or uniqueness constraint. Okay, the attribute whose values are distinct for each entity in the entity set is called key attribute. Key means uniqueness constraint on attributes. Key. This I have mentioned earlier also, just recap. So the entire entity type usually has one or more attributes whose values are distinct for each individual entity in the entity set. Such an attribute is called key attribute. Now, while talking about key attribute, we can see that in figure 7.6, we have key attribute of employee is nothing but name. So here name can be a key attribute. That means what? Especially for this employee table, sorry, this company, sorry, not this one, this is wrong. This company is actually having the key attribute as name. Okay, because we cannot have two Infosys, we are only having one Infosys, right? So no two company can be have the same name. Okay, that is not correct. Okay, so key attribute is name, because company name will be unique. So especially for this entity type, that is company, we can have key attribute, a name as a key attribute, okay? But for the person entity type, let's say some entity type is nothing but person. That means some entity in the database which is nothing but person. In that case, name cannot be work as a key entity type. Cannot be work as a key attribute, okay? Because two persons cannot have the same name. But in case of company, it can be. That is what trying to say. But in case of person, social security number. In case of person, social security number can be a key attribute. Okay, so this is there. Now, social security number will be the key attribute. Sometimes several attributes together form a key. Sometimes several attributes together form a key. Okay, meaning that the combination of the attributes must be distinct for each entity. If a set of attributes possesses this property, the proper way of represent this in the ER model that you described here is to define the composite attribute. Okay, so figure 7.7a, this one, this is A. Okay, 7.7a. This may be 7.7b. In 7.7a, we can see that each key attribute has its name underlined. So it is registration is a key attribute, vehicle ID is a key attribute, and they are underlined. Okay, that means these are unique, and they together make a composite key. And also this such kind of composite key should be minimal. So composite key in the database should be minimal, as minimum as possible. Okay, so specifying that an attribute is a key of an entity type means that the preceding uniqueness property must hold for every entity. So here we have registration number and vehicle ID, both are key actually. Okay, whether they are together making a composite key, the car entity type with two key attributes, registration and vehicle ID. Here diagram notation, B entity set with 3 entities. Okay, so here here we have registration number, vehicle ID, make, model, year. These all are the instances. Okay. Okay. So fine. Some entity types can have more than one key attribute. So here that is what I am mentioning. It is not composite key. I think I was wrong. These two are not composite key, I suppose. This is a key. This is also a key. Okay, there are 2 keys available in this car attribute, car table. Okay, but some entity types have more than one key attribute. For example, more than one key attribute. So this is also a key attribute. And this is also a key attribute. Okay. Okay, so these together are making a composite key or not, that I am not saying here. What I am saying, this is also key, this is also key. Okay, now sometimes what happens, more than one key attribute is possible. More than one key attribute is a possibility. Example is here. Each of the vehicle ID and registration numbers, registration attributes of the entity type car is a key in its own right. The registration number attribute is an example of a composite key. Now composite key is, these two are not making composite key. Sorry, registration number itself is a composite key, because you know by now, you know the definition of composite key, that whether the key can be further partitions. Okay, so here register number can be partitioned further into state and number. So register number is a composite key. A table can have more than one key. Okay, so more than one key attribute is a possibility, but register number here working as a composite key formed from two simple component attributes, state and number. State and number. Okay. Sometimes what happened that let me see whether I have that example or not. Sometimes what happened is that some attribute, some entity type might not have any key. Okay, could not have any key. Such in this diagram you can see that dependent is not having any key. So no key is also a possibility. So no key. Some table cannot. No, some table might not have any key. So no key is also a possibility. Okay. Okay. So if any entity type is having no key, then we call that attribute as weak entity. Weak entity type. Okay, weak entity type. Next, what is value set of attributes? So composite key we have understood. May have more than one keys possibility. Just now we have seen for this car itself we have two keys, registration and vehicle ID. Constant on all extension of the entity type. Next is entity type. Okay, now value set of attributes. Here, value sets of attributes. So value set means domains of attributes. So what is that? So each simple attribute on an entity type is associated with a value which specify the set of values that may be assigned to the attribute for each individual entity. So in case of figure 7.6, in case of figure 7.6, if the range of ages allowed for employee is between 16 to 70, so this is the employee age. If the range is between, let's say, 16 to 70, we can specify the value set of age attribute of employee to be the set of integer number between 16 and 70. Similarly, we can specify the value set for name attribute. This one, how can we do that? Similarly, we can specify the value set for the name attribute to be the set of strings, alphabetic characteristics separated by blank character and so on. Okay. Value sets are not displayed in the ER diagram. So here also, if we keep name to be, let's say, some character, let's say 40 character long, then more than that is not allowed. So that is a value set. That is the domain of that attribute. Okay. That means what is the domain? 40 character. What is the domain for the age? 16 to 70. That is the domain. Okay. Similarly, for salary also you can have zone domain. So this is called value set. Okay. Value set. Each simple attribute is associated with the value set. Specify the set of value that may be assigned to the attribute. That is value set for name attribute. Set of strings, just no alphabet character separated by blanks, blank character. This one is value set, and this domains is not reflected in the ER diagrams, specified using data type basic or additional. So these are not reflected in the or not displayed in the ER diagram. We are not going to say that what is the value set of the domain of each attribute. We are not going to say in the ER diagram itself. Now next is important thing, which is So value set we understood. Now value set, what happens is that we can mathematically represent value set. What can we do here? Value set, no. So what I'll do, I'll just, otherwise I can write it here itself. Okay. So mathematical and attribute A of entity type entity set E whose value set is V can be defined as a function from E to the power set of PV. Okay, E to the power set of PV. That means we can write attribute A can be a function from E to power set of V. Now what is power set? You know power set, right? If you have, let's say, 3 elements, 1, 2, 3, we can have in the power set we will be having 8 combinations. Okay, and one of the combination will be, let's say, this is attribute A1, attribute A2, attribute A3. Okay, so one possibility is that all attributes are null. So this is one possibility. Second possibility that attribute A2, A3 is some value is there, but A1 is null. So total we will be having 2 to the power 3 combination. That means total 8 combinations will be there, including the null set. Okay. So this is so null value is represented by the empty set. Null value is represented by empty set 5. Okay. So this is there. For single value attribute A is restricted to being a singleton set for each entity E, small e in capital E, whereas there is no restriction on multi-valued attributes. Okay, so single valued attributes means only one. Let's say single value, only one possibility is there. Okay, let's say name may be a single value attribute, only one name. Okay, or something else which is single. Let's say registration number. Registration number is a single value attribute, but there may be the cases where we have multi-valued attribute that we have seen. Okay, multi-valued attribute. So, and for composite attribute A, the value set V is the power set of Cartesian product of PV1, PV2 until PVN, where V1, V2, Vn are the value set of the simple component attribute that form A. Okay, so V can be written as power set of PV1 into PV2 into PV3, similarly into PVN. Okay, so the value set provides all possible values. Usually only a small number of these values exist in the database at a particular time. Okay. Next is initial conceptual design of the company database. So here what we are going to do throughout this course, we will be having this company database where we have, initially we are starting with, let's say, 4 entity types, which are nothing but department, project, employee and dependent. Okay, so first one is the department entity type. So department is attribute name, number, location, manager start date. Location is the only multiple attribute. So this is how is the department. Okay, department table, department entity type. Okay, which are the attributes? Name, number, manager start date, and location. One catch is here is that location is the multi-valued attribute. That means we can further partition this location into some street number, whatever, room number or flat number. We can further. So this multi-valued attribute is referred as oval shape and then double circle, double oval, double, what do you call it, oval only, right? So we have double oval here. So this represents that it is a multi-valued attribute. Okay. Then after department we have project. So project with attribute name, number, location, and controlling department. Project name and number are the key attributes. So here project name and project number are the key attributes. So whether these together are making a key? No, they're individually also unique. No project should be having the same name. No project should be having the same numbers, right? So they have these key attributes, name and number. But as I said that in case of employee, this name will not be the key attribute because we can have multiple employees with same name. Okay. Then we have third one is nothing but employee entity type with attribute name, SSN numbers, SSN, social security number, sex, address, salary, birth date, department, and supervisor. Both name and address may be composite attribute here. In case of employee, both name and address. Name is here composite attributes. Here location is in the earlier case location is a multi-valued attribute. Okay, multi-valued. It should not be partitioned. It's a multi-valued. So you can depend. I think I told it wrongly. So multi-valued means what? We can have multiple values for it. Location. Okay, that example you have seen in the last class. But this is composite attribute. That means a name further can be divided into first name, middle name with initial and then last name. So this is composite attribute, name. Similarly, address also could be a composite attribute. This one, address. The address can be also further partitioned. Okay. Finally, we have dependent attribute, which is having no key. Dependent attribute having no key. Okay. And then no key means it's a weak entity. Just now I told you it's a weak entity. Okay, weak entity name. So this is all about the weak entity and this thing. So this is some basic introduction to the entity type that we are going to use in our next classes. So far we have not represented the fact that an employee can work on several projects, nor have we have represented the number of hours per week an employee works on each project. So these characteristics listed as a part of the third requirement in the section. So with that we will be telling it in will be describing in the next part. Okay. So there are other attributes such as works on, that can also works on of employed entity, that also can be works on. We will be seeing that works on. That also could be a composite attribute. Okay, works on, that we will be seeing next. This also could be an attribute which is a composite attribute. Okay. Now next is the relationship types, relationship sets, roles, and structure component. Okay. So let us go to the figure 7.8. This figure. So in figure 7.8, you can see that. Let me first draw it. So here several implicit relationships among various entity types are there. 7.8. First of all, manager of department, this one. Manager of department refers to an employee who can manages the department. And then controlling department, the attribute controlling department of the of an employee who can controlling department of project. Here the controlling department attribute of project refers to the department that controls the project. Okay. The attribute supervisor. What is supervisor? This one. The attribute supervisor of the employee refers to another employee. Refers to the another employee who supervises this employee. Okay, that is the supervisor. So in employee itself we have a supervisor. So who will be supervising all other employee? That means somebody will be there some employee will be there upon which this supervisor will supervise, and might be this supervisor also may be supervised by some other employee. Okay, so it's an interesting thing. Okay, and then the attribute department, department of employee refers to the department for which employee works on. Okay, in the ER model, these references should not be represented as attribute but as relationship. Okay, so now these things are coming up. How like whether there will be one manager for a department or there should be multiple manager, and then who is the supervisor of the whole who is the supervisor, and then how many employee will be the supervisor, and whether one supervisor is for all employee, whether we can have multiple supervisor, and whether the supervisor that we're talking about also will be supervised by some other supervisor. So there are a lot of questions and relationships comes, okay, that we are going to discuss. So for that, and here you can see dependent entity type is not having any keys. Okay, so relationship types and sets and instances. So relationship types are capital R. This is called relationship types. Okay, let's say relationship types, nothing but capital R among n entity types. Okay, so this relationship is among n entity types, E1, E2 until En. Okay, define the set of association or the relationship set among entity from these entity types. As for the case of entity types and entity set, a relationship type and its corresponding relationships are customarily referred to by the same name R. Mathematically, relationship set R is a set of relationship instances. So what is this relationship R? It's nothing but relationship instances. Relationship instances which can be referred as Ri. Let's say relationship instances are referred by small Ri, where each Ri associates n individual entity. This each Ri associate n individual entities. Let's say employee 1, employee 2, employee n, employee 1, employee 2, employee n, and each entity. Sorry, not employee. This is entity. Okay, each entity. So this relationship instances Ri, where each Ri associate n individual entities, entity 1, entity 2 up to entity n, and each entity Ej. Let's say these are entity n. So here from this entity we have, let's say, each one entity called Ej, in Ri is a member of the entity set capital EJ. Okay, so this is the meaning is that what such that this J should be in between 1 to n. Okay. So what is the meaning of this? Meaning of this is very simple, that we have a relation, we have a mathematical relationship of set of mathematical relation on, let's say E1, entity 1, entity 2 up to entity n. Okay, and these entity sets are making Cartesian product among themselves, because these entities are related, and this relationship only can be created by Cartesian product. Okay, Cartesian product, and once Cartesian product is made, then this creates a relationship among all entities, and that relationship let us call as a total, it is R, and R is the set. Let's say individual relationships are Ri. Okay, so example, on example, if you see, we can understand. Okay, so here if you see, so here relationship type R among n entity types, E1 to En defines a set of association or the relationship set among entities from this entity type. Each of the individual entities is said to be participating in the relationship. Now next you see, here you can see, so there is something called degree of relationship. Just quickly let me finish it. So degree of relationship type is the number of participating entity types. Okay, so how many entities are participating in the relationship? So we can understand this thing from the diagram. So this diagram is enough to understand. So here you can see that. So here this Ri, so this is my Ri, which is nothing but works for is a relationship R, small I. So this is a part of the capital R of this small I. Okay, so Ri is nothing R1, R2, R3. So here you can see that Ri is shown connected to the employee and department. Ri is helping to connect this employee entity type and department entity type, and so employees E1, E3, E6, employee E1, E3 and E6, they are connected to department D1. Okay, department D1, and employee E2, E4 works for the department D2. E2, E4 works for department D2, and E5 and E7, sorry, E5 and E7, they both are related to the department D3. Okay, works for department D3. So in your diagram, relationship types are displayed as diamond shaped. So when you will be seeing the actual entity relationship diagram full-fledged, then this diamond is mentioning this. So diamond represents the relationship. So when you'll be preparing the whole entity relationship diagram, so this diamond will be representing the relationship. Okay. There. Now let us discuss the degree of relationship type. Is that just now I said that the degree of relationship is the number of participating entity types. If two entities are participating, then we'll call degree 2. If three entities are participating in the relationship, we'll call ternary relationship. Two entity participating means we'll call it binary relationship. Okay. And then there is something called role names. Role names means each entity type that participates in the relationship plays a particular role in the relationship, and then recursive relationship. Let us see that what is what. So degree of relationship is what? Now degree of relationship is the number of participating entity types. Hence here you can see works for, in this case, works for relationship is degree 2. Okay, degree 2, because here two entities are participating, in works for relationship. So here employee entity and department entity both are participating in the relationship works for. So it is called binary. Degree is binary, okay, and one of degree 3 is called the ternary. Okay, so ternary relationship example is this one, supply. So an example of ternary relationship is supply shown in figure 7.10, where each relationship instance is Ri. This one. Associates three entities: supply S, part P, and project let's say P. Okay. Project is, let's say, represented by J. Okay. So S, so J, I can write it like this, J. So this is entity 1, this is entity 2, this is entity 3. So this is a ternary entity, ternary type. So what is the general thing? Generally, relationship can generally be any degree, but the ones most common are binary relationship. That is what the most common is binary relationship. That means two entities are participating in each other. Okay. Next is okay. This here in this case you can see that two entities are participating, employee and department, with managers relationship. Managers. So this is one-to-one relationship. Each employee one-to-one relationship. Okay. So each employee is related to one department. Not every employee is here, but here E3, E5, and E6 is related to three departments individually. So this is a one-to-one relationship. Okay. And then finally we have okay. Finally we have this recursive. So this is a particular role that manager is the particular role. Okay. Manages is the example. This one. Manages these relationships. Okay, we're talking about role names. And third one is the recursive relationship. What is recursive relationship? Same entity type participate more than once in a relationship with different roles. That is called recursive relationship, such as supervision relationship. Very interesting. Supervision relationship. You can see that here. So recursive relationship supervision between employee is a supervisor role and employee is a subordinate role. Okay. So what exactly happening here? So this is called recursive relationship. Okay. So here the supervision relationship types relate to an employee to a supervisor, where both employee and supervisor entities are member of the same employee entity set. Hence, employee entity type participate twice in the supervision. Once in the role of supervisor or boss, and once in the role of supervisee or subordinate. Okay. So each relationship Ri, this is Ri, each relationship Ri in supervision associate two employees EJ and EK. EJ and EK. So this relationship R1 associate two relationship EJ and EK. Okay. So here you can see that from figure 7.5, the lines marked one represent the supervisor role. Sorry, not this one. Marked 1. So EK is a supervisor. E5 is a supervisor. So you can see that. Okay. So this marked 1 represents supervisor role, and those marked 2 represent the supervisory role. Hence, employee E1 and E2. Let's say this is E1 and this is E2. Let me run it. So what is happening here? What I'm saying that here figure 7.1 shows an example. The supervision relationship type relates an employee to a supervisor, where both employee and supervisor entities are members of the same employee entity set. Hence, employee entity type participate twice in the supervision. Once in the role of supervisor or the boss, and once in the role of supervisee or the subordinate. So each relationship instances Ri here in supervision associate two employee EJ and EK. EJ and EK. Okay. One of which plays the role of supervisor and another one is playing the role of supervisee. So in figure 7.1, the lines marked with one represent the supervisor and lines, let's say this one, mark 1 represent the supervisor role and those mark 2 represent the supervisory role. Hence, E1 and E2 and E3 and E4 supervises E6 and E7 and E5 and E1 and E4. Meaning is that here you can see that E1 supervises E1 supervises what? So what it says that E1 and E2, E1 and E2, E1 supervises E2, E1 supervises E2. So E1 supervises E2 and E3 E1 because this is one marked as a supervisor. Okay, E3, this one I'm talking about. Okay, and okay, this is clear. And E4 supervises E6, E4 supervises E6. This is one just gone there. So E4 supervises E6 and E7 also. Okay. And E5 as well, I think. Okay. So this is how things happened here. So fine. So this is how supervision, this relationship can be poised two ways actually. Okay, employee can be supervisor, employee can be supervisee. Now cardinality ratio for binary relationship specify the maximum number of relationship instances that an entity can participate. 1:1, 1:n, m:n. Participation constraints specify the minimum number of relationship instances that each entity can participate in. Total participation, partial participation. Okay. If all instances, all employees participating in some relationship, then we'll call that total participation. Okay. And then we have something called structural constant of a relationship type. Cardinality ratio and participation constant is called structural constant. So here you can see that n:n relationship. That means as many employee can participate in as many projects. m:n relationship. One works on. Okay. So you can see that employee 2, second employee 2 is participating works on relationship in project P1 and project P4. Employee 3 also doing so. So it is participating in 3 projects, P2, P3, P4. So this is m:n relationship. This is cardinality is m:n. And then finally we have this summary of the notations for ER diagrams, symbols. So this rectangle is for entity, Double rectangle, weak entity. This diamond is for relationship. Double diamond is identifying relationship. Attributes, oval shape. Key attributes, underlined. Multiple attributes, double oval. And then composite attributes, if the attributes is partition further. Derived attribute, we have seen derived attribute. Derived attribute was nothing but age if date of birth is given. Total participation of employee E2 in R. Employee E2 is participating totally. Coordinated ratio 1:n for employee E1 is to E2. That means one employee is participating to all other employees in some relationship. And then structural constraint, mean max on participation of E in R. Okay. That examples we will see. So this is a complete ER diagram. You can see that complete ER diagram, everything is there. Okay. So here the participation of dependent is 1:1. That means one employee is dependent. So this employee table, each employee has dependency 1. So this is 1:1. Supervision, you can see that supervision. Okay. Then here it is 0:1, 0:1, continuity, 1:1, 0:0n. Okay, then works for is, you can see that works for 1:1, employee works for employee and department 1:1 relationship. So this is how things happened, and we will see more detail in the next class. Okay.